Welcome back, everyone, and today is going to be a fun new video. In the last video, we did a sphere, and we basically did like a physics motion to it. We had its rotation and its velocity connected together, so they're perfectly in sync. You figure out its velocity based on its rotation. So this way, we're able to move the sphere around the entire level, or the entire white space room that we have. That was really just one sample of kind of like starting to move characters around in a physically kind of way, because there was one GDC talk that used something called a stride wheel, and the stride wheel did that. Was how he approached moving characters, like as they walk. So he pretended that they're basically kind of just animating their legs, and he's just animating, he's moving them based on like a wheel type of thing. So it's based on a wheel type of motion. For my armature, I decided I was going to do that, but then I wanted to try something more IK rig like, which is you move where your foot wants to go. It's the physics. It's wherever your foot pushes you is where you should be going. So that's what this video is going to be about. It's going to be about moving our armature. We're going to start moving our armature in forward direction. Well, technically, in whatever direction it's supposed to be animating, and at whatever speed that it kind of animates at. So, further ado, let's get straight to the code. I just had this as a nice backdrop because I don't have nothing to show you other than code. All right, then. Excuse me. Like I said, I'm doing a bunch of videos in one day, so I have like a bad voice. So this is kind of our armature that we kind of left off, and now we're going to kind of add some new things to it. So we're going to be using our walk animation, and what we want is that when the foot touches the floor, it moves our character forward. So we need to keep track of its position. So I have like an object here, previous position 1, previous position 2. I keep track of the position of where the foot is as it animates. So for this example, for every frame, I check to see the position of the foot where it currently exists right now. If the foot is about less than or equal, should be less than or equal to, but less than this value, that means the foot is basically touching the floor, because the floor is at 0. So I'm getting that little range, the little buffer space. So if the foot is within this range of the floor, do something. So in what I'm doing is that I'm taking the previous position. Like I said, I'm tracking the position no matter what. So I take the previous position, subtract from its current position. That basically tells you within one frame of animation, how much velocity happened with the foot. So if the foot was moving slowly, the velocity would be slow. If there's a big gap between it, that means there was a lot of velocity. There was a fast movement. So that's the only thing you need to kind of do is keep track of where the foot is. And then, like I said, when it's touching the floor, start doing something with it. So we have its velocity, right? So we want to move it in forward only. If I want to actually do a real movement, I'll probably do the Z and X. So this way I can have a foot push me sideways or diagonally. But for right now I just want to do just forward motion. And if I want to do forward motion, I should just lock it to the Z axis. So this I'm just animating in that one direction, based on the animation. And I do everything at local space, not world space. So this way, I do local space. Do I? No, I'm actually doing everything world space, right? Transform the position into world space. It's world space. Okay, sorry. So yeah, I am doing world space. So that's it. That's really the gist of it, and that's just one foot. I have everything else commented out. So if I come back here, I go to skeleton. As you can see, when the left foot touches the floor, it actually pushes my character forward in the Z-axis. It's simple, right? Foot touches the floor, foot moves. It basically adds that. So if I'm, well, I probably didn't explain this one part. I'm doing the opposite of whatever. So if the foot is going backwards, that means I want to move forwards. So whatever velocity it is in the backward motion is a forward. So if I was able to flip the animation backwards, where I'm animating the other way around, which I don't think I can I? Can I do it easily? Maybe if I do this, I don't know. Let's try it out. Let's see if I can make the cycle happen back. No, I don't think it can happen backwards. Can I? No, I'm doing it wrong. Like I said, I don't like to code in real time because I'm an idiot when I'm actually coding. I look smart when everything is pre-done. I didn't build it into my engine to go in reverse. That's the. Wait a minute. What's the value? I don't want to waste too much time on it. Is there like a quick, easy way? Offset? No. Oh, you know what? All right, I'm going to just one last attempt, and then I'll quit and move on. There you go. I flipped it. There you go. And it's just, as you can see, since it's basically based on my movement's based on the movement of where the foot is. That means you can use any animation, and you just have to make sure the foot touches the ground. And once we do, let's say, inverse kinematics, that means we can always force the foot to touch the floor when it's within a certain range. So if it's in a certain range, we'll use IK to move the foot so it's touching the floor, so it looks like it's really walking on the floor. Like if it's going up the stairs or anything else. Like if you're going up the stairs, maybe you want the y-axis added to your velocity, so you're kind of going up a little bit and everything else. But as you can see, I'm not pretending the character's moving forward. I'm not adding a velocity. I was able to just change the animation, and the character now moves based on where the foot is going. So if I were to, let's say, add the other foot to it, click refresh. Now it's walking backwards in every foot. Every foot does the job. So I don't want to make it walk backwards, but in case you're wondering how I figured it out, because I said negative to this, so it's negative plus that, and that made it really slow motion. But if I add them both together and then say it's a negative, then I take the actual. See, so sometimes I am smart. I need to do something stupid first. So there you go. Now it's walking forward. It's got that, like I said, once the foot touches the floor, it moves. But that's not really realistic. You got to think about it. That this is kind of like, this is essentially a physics type of thing, I believe. I can't, don't quote me on that because I don't know what I'm talking about. But I'm looking at it as a physics thing, right? So when the foot moves across the floor and it pushes, it's basically applying a force. It's applying a forward motion to the object. So it doesn't just stop. It's like this is like you have like infinite like friction or something, or I don't know. I'm wrong, but it's like you have like this incredibly high amount of friction that stops you the moment the foot's off the ground. In all honesty, when you start moving, your body kind of moves. It has a certain velocity forward. So, like I said, when I'm sitting there figuring this out, like I said, as you can tell by the test function, and in case you haven't realized, the test function is here. So I update the animation, and then I run test. All right, so now you get the idea. We're just moving in that direction, but we don't want to just basically I don't know what the word is, just forcefully push ourselves forward. Let's like a real physics. You have a momentum. You basically have a momentum. So let's keep that momentum going. So I'm going to use the movement system from a video I made a couple episodes ago. and there you go. So I'm just going to use the movement system. So I'm just going to choose a velocity. So my forward velocity, it's the same thing, but instead of just moving it per frame, I'm just like, okay, well, this foot is currently this is animating at this current velocity. Make this character forward velocity the same way. And then take that velocity and do a per second multiplier on it. Because the velocity system is based on speed per second, and this is speed. This value is basically speed per frame, and so I don't know what. So to make it work correctly with the velocity system I made, since the value is per second, I just take delta time and just say it's one. I just want to multiply it by delta time. No, yes. Delta time is time per second, so this gives me like the correct multiplier for it. So I multiply this. We'll make the velocity bigger. Damn it! I can't reach it because it's behind the camera. And I took out the other phone. Damn it! I'm sorry, guys. I had to take both phones out of the room when I'm recording. Damn it. All right. I'm sorry. All right, so so I'm multiplying. I make sure the velocity encompasses how fast I want it to go per second, essentially. Like I said, the velocity, the movement system I built it to be frame rate independent. So so who cares about that, right? Because we're caring about movement. So, like I said, when your foot is moving, it's pushing you, it's giving you a forward momentum, so it should be a constant type of velocity. So if I move it into a constant type of velocity, as you can, there's a slight pause because I think I have friction turned on. So by friction, the moment the foot is off the ground, I start to slow down a little bit. But there you go. But that's a very more accurate way of movement. You can always sit there and tweak it a little bit. Maybe if I take out friction, do I have it commented out somewhere? I don't know. No. I think I have it in the other example. But like I said, this is really just the gist of it. This is all you really. This code is the bare essentials of taking your animation and figuring out how fast the character is moving, and just apply that velocity to your character. You can sit there and tweak it a little bit to make it a little bit better, but overall, it's going at the right pace that it's supposed to be going. So if I were to swap out, because there's no initial value, so it's sometimes a little wonky when it starts. But that's like I said, that's how fast the character is actually walking. If I take away friction, you don't get that foot sliding thing. That's why I wanted the friction there, because so the foot doesn't slide at all. So it really, you're moving. I'd probably just need to tone down the friction just a little bit more. That's about it. But I have like a global value, so I need to update the movement system, so maybe each object gets its own friction value capability. So this way I can fine-tune the armatures to use a little bit less friction. So this way everything is a little bit more smoother. But overall, it works. Without that, now we can use. Now I took like that test function and made a little system out of it. Let's see if we go into the system part. Don't need that anymore. So I made a new component, right? And I didn't build it as a system. I built it. No. I just built it as an object, didn't I? No. I built that as a component. But I have no system for it. Okay, I didn't build a system for it. I just had built a component. So it's kind of like a mix. And this doesn't follow ECS rules at all. This is bad code, ECS wise. But like I said, I want to quickly prototype this. This part will probably be in the. I might make a system. I don't know. Whatever. Who cares? Let's not bother with that. So again, like I said, just like the test function, I'm just keeping the track of where the foot is, and then minimum distance is just how far from the ground do I really want this to start animating correctly. I think once you start doing IK position, it becomes a lot easier, because let's say if IK kicks in saying, okay, you're within a certain range, I can probably set a flag saying, okay, do movement, because it's still it's touching the floor. Once it's not touching the floor, it just use whatever velocities you currently be using. So so we're transforming both feet to world position. Right, and then we calculate the velocity for each foot. Then I just add the two velocities together, and just add it. And I have friction turned off for this one, but this one allows me. This one's different. Because I saw, I think the test function. To me, if there was something a little off by it, and the way I fixed it was, once the foot's on the floor and I'm moving, I have friction turned off. Once either foot is no longer touching the floor, that's when I turn friction back on. So this way it makes the motion look a little bit more realistic. So it's only when you have forward momentum and you're not touching the ground is that when you start to slow down. Because gravity pushes you down, and you have wind resistance. You have all this other crap that physics can name, that has all these applied forces against you. And then when all said and done is this. So it's really a more cleaned up, nicer version of that test function. And if click refresh. And it feels like this one, to me, feels a little bit better, because I don't have friction when the foot's on the ground. But only when both feet are completely off the ground. So there you go. That's it. Very simple, right? Like I said, again, a very small function that really does the trick for us. And the beauty of using your feet is because, like I said, you can change the animation. I can switch it to the jog animation. And like I said, I don't need to guess how fast it's going. I really don't. There. It just travels at the speed of the actual character is actually traveling. Now I got those errors going on. Because I need... Where is it? False. Include the whole armature. No! I hate when that happens. The save button and the close button are right next to each other. So that's the jog. That's the full body jog. I hate when I do that. Refresh. Oh, damn it. I gotta do something else. I have a follow camera, but this follow camera stinks. It doesn't allow me to rotate. I think that's the other setting. Nope, still no good. Alright. Oh, you know what? I'm dumb. I can just use a... Oh my god, I am so out of it today. I haven't had breakfast or coffee yet. That's right, I can use the zoom. Oh my god. No? I can't zoom? The hell? Well, that sucks. Something's broken. I don't know what's broken. Nope, can't figure it out. Alright, whatever. But yeah, it animates. Something's broken in this sample. I must have broke something. I have the follow camera, but What's the follow camera doing? Well, I don't want to waste too much video time dealing with that. So I just want to show you that you can very easily just animate, move your character based on its foot movement. And here's the Ninja Run sample. Refresh. And since it's going slow speed, like I love that friction that happens in between when the feet are not touching the ground, because it's more realistic. Because you do slow down. You got that nice bounce going on. It's great. And like I said, last example, I could just change the speed up, and like I said, whatever the foot's going, there you go. I think Unity might have a feature like this. I can't remember anymore. But yeah, this is I wish I can control the camera. I have no control of the camera right now. I don't know what happened to the camera. I can't control the camera. Yeah, whatever. All that matters is the foot movement, foot movement thing. So yeah, that's that. So yeah, if you guys want to leave, you can now at this point. I'm probably just gonna set this up to just walk again. So I can end it. So there you go. So that's great. Like I said, this is great. It runs smoothly. Like I lock everything to the z-axis. But if I was going to do like a side strafing, I can just take the velocity of x and y, or the x and z values, and that'll do the trick. So this way it'll move me in diagonal directions or everything else. So you can actually have all your animation drive your motion. And that's all. And all you have to do is just track where the foot is. Always track its previous position. So this way you can then calculate its velocity when you need to calculate its velocity. And it becomes a very simple thing. So this way I can take this foot movement thing once I have a system as a component in a system, and I can just apply it to any armature, any characters on the scene, and they'll just walk at the velocity they're going. And the beautiful thing is like slow motion. Like if I want to slow down the animation, that I don't have to recalculate the speed of the character, because it just takes into account of how fast the foot's moving. If the foot's animating slowly, then the velocity will be slow. Everything kind of just is connected. Everything just works together, very simple, very easily. Yeah, and I like how the ECS framework is really helping me prototype. I would just throw things in there and just build up. And eventually, once I have all the little pieces, sit down and then restructure it, recode it or refactor it into one unified system, hopefully. But yeah, there we go. Like I said, we got motion. We can move. We can calculate based on feet, and it's all animation based. It's awesome. And like I said, the animation is procedurally generated. I didn't use any tools or anything to animate this and to move this. Everything is just coded there. So that's kind of really one of my goals of recreating the IK system. It's just having animations that can piecemeal together and have it kind of control the character, or at least give it some motion, Yeah. So yeah, that's it. That's the end, really. Hope that's 24 minutes. That's pretty good. I had 24 minutes. Yeah. After this, I'm gonna start dealing with inverse kinematics. I got that working yesterday. If you follow me on Twitter, you'll see my progress on everything. Because that's when I post pictures and I do like Dance of Joy tweets saying, yes, I figured it out. surprisingly, I'm doing a lot of this on my own, so I'm actually pretty happy because I'm not. Other than the initial coding math walking cycle concepts of how to make it work, I'm just kind of just flying with it. I'm just going with it, and so far my ideas are working out pretty well on how to approach this. There might be better ways of doing it, in all honesty. But yeah, like if the foot touches the floor and it moves while it's touching the floor, you go in the opposite direction, and it works. Um, so yeah, this is now the camera works. What the hell? The zoom doesn't work. All right, whatever. Just watch the foot walk off the edge, and hopefully once I have physics built in, once he walks off the edge, he'll just fall. And then if I know he's falling, I can switch up the animation. So there's a couple more things we have to do down the line. I want to transition between animations. So these systems have to be fixed up where it creates a frame of data, and then have like a lot of this stuff. It just animates for me. But what I really need to do is restructure everything so it builds a frame of or like final destinations of where I want things to go, and then I can kind of then alert between everything. So this way I can easily transition between animations, as long as I have them as like single frames of things. So let's say if I have frames of two poses, I'll alert between the two poses. If I only have one pose, I'll just animate that pose. So that's maybe the way of thinking how I'm going to do it. So this way I can start. So down the line, I'll probably do transitioning and posing and things like that. But like overall, so like maybe figure out a way where I have this walking animation and I transition into the ninja run animation. Maybe that might be a fun example. Once I have to restructure the system where, like I said, right now I can only do one at a time. So, but overall, the system is building up really nicely. Like I said, this is great. I'm freaking ecstatic about this. This is totally awesome. Yeah. I'm gonna do a tentacle one next. I'm gonna have tentacles with IK movement. So I got the IK movement, but I don't got like it animating so it kind of just calculates where it's supposed to go, and then it just makes that pose, and it's a freeze frame. But I got, like I said, it that works. Now I just got to make it animate. And I want to do a tentacle, and then once I get the tentacle working with IK, I'm going to go do the IK rigs from Ubisoft's idea, where their concept is you have it doesn't matter if you have just one joint of movement or 8 joints of movement. This one animation will work for both systems, for both chains. So it's kind of like a chain animation, and I sat down and contemplated and tried to come up with a solution. I almost got a solution for that. So that's going to be another future video where we're going to have this motion stuff again with IK, but we're going to build it, like I said, closer and closer, try to get to that IK rig from Ubisoft type of functionality. Because if you watch their 1 hour demonstration, it's amazing. It's absolutely amazing. So if we can have that system ourselves, and especially if it's open source, that means everyone can have it. So we just need someone to build it and teach people how to use it and how it works, and then it can just go on forward. So like I said, Ubisoft basically gave us all the clues and tips of how they do it, but now we got to figure it out on our own how to get there. So, and I'm having fun. This is totally awesome. I have to admit that getting laid off kind of sucks, but it might have been one of the best things to happen because I have so much time to do this, and this stuff is so time consuming to do. A lot of my videos before were a lot of small things, simple effects and things. Now I'm actually building huge systems because I have so much more time to do it. So it just worked. It just worked out. So. It's always the bright side of things, Being laid off sucked, but I got my time. I got time to do something, and it's not gonna last forever. I have to get a job and take care of my family. But until that day, I'm really gonna push forward as hard as I can. Work night and day and get this stuff working. So but before I don't have the time anymore. But yeah, this is great. I love it. I hope you guys are enjoying it, because this is really great stuff. I really like it. I can't really express how much I'm enjoying doing this. All right, I added probably like 6 minutes worth of bullshit. So I guess I just got flagged. Damn. Oh well, that's all right. I don't get ad revenues from videos anyway. So that's it. See you guys in the next video. Hopefully we'll do some basic IK stuff. Hopefully once I get that animating a little bit. And yeah, we're just going to keep plowing forward. We're going to try to build an animation system for our armature. So this way we'll have things climbing and walking and running, doing everything. Doing everything we needed to do. And then once that's all done, start building collision and physics. So this way we have things, so the character can actually do things in the world. Because I need physics. I need to be able to have it fall on the floor. I need to do more ray casting and collision detection, so it can know there's a wall in front of it and do something because there's a wall in front of it. Hey, climb that wall or go around that wall or just run into the wall and just collapse on the floor, whatever. So yeah, there's still so much that needs to be built, but I really want to get a lot of this animation stuff working, just transitions and building animations in piecemeal kind of way. And I don't know, I'm just super excited. It's like if I had coffee, I'd be talking like 1 billion miles a second right now. But yeah, like I'm passionate. I love this. I'm very passionate. I've been wanting to do this for my whole life. I always thought I was stupid and not smart enough to do it and not smart enough to understand it. And I'm 38 years old. I finally, for the last almost 2 years, I guess when I started at 36, finally decided to try. And I've been doing this for 2 years, and I can't believe I'm doing this. I'm able to do this right now. It's amazing. And I'm sharing my information out to you guys, so this way you guys can do it too. Oh yeah, I almost forgot. I was going to do this. While I was recording the video between this and my previous, while I was recording, someone sent a message on YouTube. So it's ya boy. I was just want to do a quick shout out because I said, oh yeah, I'm gonna, just for fun, I'm going to do a shout out. So big shout out to it's ya boy. Thank you for watching. I really appreciate it. I appreciate all of you. Anyone who sits there and watches and learns something, I love it. Thanks. And you guys will teach me things. I'll teach you guys things. That's how it all works. It's all about open source. It's all about free knowledge. So that's what I'm really about that. So yeah, that's it. And I do like Jay Fla. She does some really good covers. So, and I know I'm not trying to get a job at Google because I don't think they'll let me do armature and systems. If they do, Google, if you're hiring for someone to build an armature system, I'm available. All right, my throat's starting to hurt. I'll see you guys in the next video.